Hi guys, so in this video, I'm going to teach you how to measure both current and voltage drop in a circuit. So we know that in a simple circuit like this, in a series circuit, we just have our battery pack that's providing the potential difference for our voltage. Our voltage source, remember, is just the amount of push that the electrons get to create electricity. They don't actually make the electrons are already in this wire, and the voltage is able to push the current through something like a light bulb and light it up. So remember, current flows from positive to negative. So I have positive going in, voltage drops across this light bulb, and then voltage should be approximately equal to 0 as we go around. We want the lowest potential to be entering in at the lowest part of the battery, the lowest part of the potential. So remember, positive is high potential, negative is low potential. So let's say I told you guys, okay, measure the total current of the circuit. What I would have you guys do is grab this thing. It's called a multimeter because it literally can measure multiple different things. And right now, this black probe right here, on the end, it literally is just like a little black probe that you can touch different points in the circuit with, and so is the red one. But the black one is negative, and I'll explain what that means in a second, but the red one is positive, kind of like how I oriented my wires in my simple circuit. Positive flows around to negative. You don't have to do that, I just like to show it to be a little bit more clear. All right, so right now it's off, but my red probe is plugged into the left side that has amps. So if I want to measure current, am I going to keep it here, or am I going to plug it into this hole over here that has volts and ohms? Obviously, I should plug it into the left one, right? I'm measuring amps, which is the unit for current. So I flip my multimeter switch to the yellow dial. You can barely see that, but it says 10 amps. Okay, that's the limit for how much current this multimeter can measure. Up to 10 amps is what that means. And now, just like before, I'm going to ask you to measure the total current of the circuit. The way you do that is connecting this multimeter in series with the circuit. So you literally have to break the circuit. It was originally closed, the light bulb was lit, and now we broke the circuit, so now it's an open circuit. I'm going to place my red prong, the more positive end, where the alligator clip was, right next to the positive end of the battery, and I'm going to touch the negative or the positive end of the bulb. And right now my multimeter is reading 0.3 amps. So the total current of this entire circuit is 0.3 amps before it gets into the light bulb. We know in reality, right? Kirchhoff's law says that only voltage drops in series and all current should stay the same. So if I were to say verify that statement, we can also test the current on the other side. So 0.3 amps here better equal 0.3 amps over here. Remember, the red probe goes on the more positive end, flows from high potential to low potential. This is my higher potential point. I broke my circuit. I'm replacing my alligator clips, my bulb lights, and I see what reading I get. And I get 0.3 amps. So there we go. I verified Kirchhoff's voltage law, right? Well, the other half of it. It just says that in series circuits, current remains the same because there's only one path for current to flow, and then in parallel, it will split. So let's go back. Let's plug these things back in. And let's say I said to measure the voltage. How much voltage is flowing through this circuit? Well, I know conceptually that the total amount of voltage in this battery pack better all be dropped through this light bulb so that it returns to its original lower potential, our 0 point voltage value. So that's what I'm going to do. And the way you measure voltage on the multimeter is by doing this. So remember, the left one you measure for current because you use amps. So I'm going to plug the red probe into the right side since the multimeter says this is what you use for voltage in ohms. I'm going to go to the voltage setting. See that it has a little capital V. And you measure voltage in parallel. So remember, we measure current in series And the way, instead of the word multimeter, you might see the word ammeter, means that it measures amps. And then if you see the word voltmeter, it measures voltage. So you connect an ammeter in series, and then you connect a voltmeter in parallel, which means you don't even have to break the circuit to measure voltage. All you have to do is take your red probe, put it on the more positive end, take your black probe, put it on the more negative end, and I get about 3.07 volts. So the entire voltage of these three batteries is 3.07 volts, so we can verify that. I'm going to measure the voltage of just the battery pack. But wait, Miss Kolova, that's higher than 3.07 volts. The reason why it's more is because, remember, voltage not only dropped, but there was a little bit that had to escape to create this light in the bulb. If this was a true resistor that barely had any heat to it, that didn't heat up too much, you would see those two values be nearly identical. And that's how you measure voltage and current in a simple series circuit.